We start off chapter 2 with section 2.4, where we look at reasoning in algebra. What we're actually going to do in this section is combine what we know about algebra and solving equations, combine that with some of the geometry that we've already worked on this year to solve problems similar to what you've already done. But now we're going to have to give reason or explanation or tell what we use or why we did something, how we did something with each step. Basically, what we're starting to gear up for is to complete proofs. So before we can actually start working on the problems, we have to just kind of refresh with ourselves some of the properties that we use every day when we solve equations and solve math problems. So with an equation, the property that allows you to add the same value to both sides is called the addition property of equality. The subtraction property of equality allows you to subtract the same value from both sides. Multiplication property of equality allows you to multiply both sides of an equation by the same value. And division property of equality allows you to divide both sides of the equation by the same property. These four properties are actually what we use every time we're solving an equation to find the value of a variable. You may not remember the names of them or that they even exist, but this is actually what we do every time we solve. Some other properties we're going to be responsible for knowing. The reflexive property of equality just says that the measure of something is equal to itself. Kind of should make sense. We have the symmetric property of equality. So if you look at two things that are equal measure, that you're able to switch the order, which one comes first, which one comes second, and it's still going to be equal to each other. Then you have the transitive property of equality. So here in our example, if A is equal to B and B is equal to C, because B is equal to both of those A and C values, A and C also have to be equal to each other. That's again called transitive property. Something we do use all the time is the substitution property of equality. When you have an equation, you can replace a value in the equation with anything else that is equivalent. And then lastly, the distributive property. If you have A times the quantity of two terms being either added or subtracted, you'd be able to distribute that outside value, multiplying it by both terms inside your grouping symbols. So here's an example of a problem that we've solved other problems similar to. But now notice in the problem itself it says we have to justify each step. We have to tell what property we're using or how we know we can say what we just put on paper. So the first thing that we're always going to start with is the information that we're given. So in this case, I have to state that the measure of angle AOC is equal to 139. The reason I know that is that it's given. Now, if we look at our diagram, we may choose to go ahead and add the fact that we know this is 139 degrees. And we've worked on problems like this in the past where if you have a total value for a large angle that's divided up into smaller angles, you can take those smaller angles and add their measures together. So for example, the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Now earlier this year we had something called the angle addition postulate. I'm okay with some abbreviation here. So angle addition postulate. Or even better, let's abbreviate angle addition postulate. We can use AAP for that. We'll know what we're talking about then. So now if I know that those two smaller angles add up to be my larger angle, once I have written out the equation using the names of the angles, I can go back and replace those names with the actual expressions that I have in my diagram. So in place of measure of angle AOB, I can put x. In place of measure of angle BOC, I can put 2x plus 10. And then again, measure of angle AOC we were given was 139, so we can put that in as well. The property we just used to write that step, not subtraction, this was substitution. Now we've got an equation, we just need to solve. So we would need to take and rewrite this as 3x plus 10 equals 139. Okay, you can either call that your simplify step, or some people prefer to call it combine like terms. Either one would be fine. Now the next step, we'd have to subtract 10 from both sides, so we get 3x equals 129. That's the subtraction property of equality. I'm going to be all right if you just write subtraction. And then lastly, we'd have to divide by 3, so that x equals 43. And we there used the division property of equality. So this problem is now done. We've solved for x like it said to in the problem, and each step we took, we wrote down either how we knew the information, what we used, postulate, definition, property, whatever the case might be, what we used in order to arrive at that step in the problem. So our next problem, we're doing the same basic thing. We have a geometry problem that similar to what we've worked on already this year. Now I have actually all the steps on the left side completed for you. Your job is going to be to fill in the justification or the reason that you are able to say each step. So we'll start this off. Notice we have a diagram, we have some given information. Start out by what it is that you're always given. So we know that ray LM bisects angle KLN. That reason that we can say that is because that is our given information. Now, once you start writing out these problems and once we get into proofs, it's always going to be a good idea for you to put any markings that you can into your picture, kind of like I did on the last one. I showed that we knew the entire measure of the angle. So this time, since we know we have an angle bisector, it would be a good idea for me to go in and show what the angle bisector would be. Show that those two angles would be congruent. Well, if I'm trying to solve for x, the next thing that I have to be able to do is write an equation. Since I know I have an angle bisector, we have to remember that an angle bisector gives us two equal angles on either side of the angle bisector. So that's what I write for my next step of work. This would probably be a step that you wouldn't write typically, but when you start adding reasons and justifying, this is a step that we will need. So here we have the measure of angle MLN equals the measure of angle KLM. And again, that's by the definition of angle bisector. How did we know that those were equal? Because we knew we had an angle bisector. That's the definition. So now what is the reason that we are able to write down 4x equals 2x plus 40? This would be using the substitution property of equality. I'm fine if you just write substitution. No need to do extra writing at this point. Now, what property are we using to arrive at 2x equals 40? That would be the subtraction property of equality. I used to make students write property of equality. I'm not going to worry about that this year. So if you just write subtraction, you will be perfectly fine. And then lastly, how do we finish with x equals 20? What property are we using to get to that point? That would be the division property of equality. If you just write division, that is perfectly fine. So here we have a problem where you're asked to solve for y and justify each step. Notice your given information here in red is not on your notes. Well, actually, maybe it is. I don't remember if I updated your notes or not. So if it's not there, go ahead and write it down. And then what I want you to do is I want you to pause the video and I want you to go through and write out all the steps that you would need to solve and write out all the reasons or the justifications for each step. And we'll talk about these when we're back together. So lastly, we talked about a bunch of properties of equality before. If you look back at the front of your paper, you'll notice they all have equal signs in them in the examples. We also have properties of congruence. And some of these, or these are the same as some of those properties of equality. So the reflexive property of congruence says that a segment is congruent to itself. Now we're not talking about the measure or the length anymore. We're just talking about the actual object itself. Same thing with angle A being congruent to angle A. Reflexive property of congruence again. The symmetric property, again, is the one that flips the order around. So segment AB is congruent to segment CD. If you just flip them around and say segment CD is congruent to segment AB, it's still true. It's still the same true statement. And then lastly, the transitive property of congruence. If angle A is congruent to angle B, but then angle B is also congruent to angle C, angle A and angle C would have to be congruent to each other because they're both congruent to the same object. They would have to be congruent to each other.